This video is adding and subtracting in scientific notation. Let's start by reviewing a little bit about what we know about scientific notation. For a number to be in scientific notation, it needs to have three components. The first one is only one digit may be to the left of the decimal. Alright, this number needs to be, so the number needs to be greater than or equal to 1, and it needs to be less than, so it needs to be a number less than 10. So that's the first rule. The second rule is it must have a multiplication sign. The third rule is there must be a power of 10. So those are the three rules of scientific notation. So for instance, if I have 2.35 times 10 to the third, this fits all the criteria. I only have one digit, which is greater than or equal to 1 and less than 10 in front of my decimal point. I have a multiplication sign, and I have a power of 10. Now this number, on the other hand, is not in scientific notation because I have a number larger than 10. So I would need to move my decimal one place here and change it to 10 to the fourth. So this would be in correct form. So now let's look at the rules for changing numbers into scientific notation. We use the rule of Joule. D stands for if the exponent goes down, then my decimal place needs to go to the right. R means if you're moving your decimal place to the right, then the exponent needs to go down that same number. U is if the exponent goes up, then I'm going to move my decimal point to the left. And if the decimal goes left, so if I move my decimal to the left, then I want my exponent to go up. All right, let's look at some examples of this. Here's my first number, 5,647. It's not in scientific notation form, and it says change the following numbers into scientific notation. So, in a way, this is like 10 to the 0. It's not quite in scientific notation because I need to move my decimal point. How many places? 1, 2, 3. And that would give me 5.647. Now you'll notice I moved my decimal place to the left. That means that my exponent needs to go up. I moved it 3 places, so I need to add 3. So I end up with times 10 to the third. Let's look at another example, number 4. Let's do problem number 4. Let's say I multiply this one times 10 to the 0, because that doesn't change the value. I really need to move this decimal one place to the right so that it follows the first rule. That will give me 9.4568. That follows the criteria because I only have one digit to the left of my decimal place. I moved it one place to the right. Right means down. Because I moved it one place, I have to take away 1. So I would get times 10 to the negative 1. Let's look at example number 6. Now I want to convert it the other direction. So I want to turn this into a correct form of scientific notation. That means my decimal has to go here so that I have one decimal in front of, or one digit in front of my decimal place. I have to move it 1, 2, 3 places to the right. If you look up here, right means down. I moved it 1, 2, 3 places, so I'm going to subtract 3, which gives me 4.0 times 10 to the second. Now this part is important for showing your work. Let's do another example. Here I have 0.275 times 10 to the negative 5. I need to move my decimal place 2 places to the right, so I get 2 75/100. Because I went right, I'm going to take away 2. I started with a negative, so I need to DPS this, and I get times 10 to the negative 7. Now use the rule of Joule to change the following numbers into standard form. Now, if I have it to a negative 3, my goal is to get that to be 10 to the 0, because then it's just multiplying it by 1. If I add 3, that'll give me 10 to the 0. Alright, well, adding 3 means I'm going to make my decimal go up. So I need to move to the left. My exponent goes up, I need to move to the left. So I'm going to go to the left 3 spaces because I'm adding 3. So 1, 2, 3. Put your zeros in, and you get 0.0048502. Let's do another example. Number 12. I need to add 7 to clear my exponent. It means I'm going to have to go 7 places to the left. So 1, 2, 3, 4, 5, 6, 7. So now I've got and that would be my answer. Alright, now if you remember from last year, we learned about adding numbers in scientific notation. You don't want to have to convert these large numbers into standard form and then add them. So we've learned a process of leaving them in scientific notation. The problem is, to add them, these numbers or exponents have to be the same. So I need to convert one of these. You usually want to convert to the larger number. In this situation, it's the 5. So I want to convert 3 to a 5. So I'm going to add 2. Because my exponent's going up, I'm going to go to left. So 1, 2 to the left. So this is going to become 0.0812 times 10 to the 5th. So now I can add these two. So I have 1.35 plus 0.0812. Add some zeros. Remember, in addition, you need to line the decimals up. Get 2, 1, 5, and 8 is 13. Carry my 1. That makes this a 4. Bring my 1 down. I still have a decimal that's in the correct form with only one digit, so I'm going to write it here, 1.4312, and then I had it times 10 to the 5th. And that's my answer. Let's look at problem number 16. I have 111 and 109. Well, I want to convert the smaller one to the larger one. So I'm going to add 2 here, which means I need to go 2 places to the left. So that will give me 0.0534. So 9.99 times 0.0534. 3, that gives me 14, carry my 1, gives me 0, carry my 1, and I get 10. So now I have this decimal times 10 to the 111th. But there's a problem. This is no longer in scientific notation form because I have 2 digits in front of my decimal place. I'm going to have to move 1 place to the left. Well, left means add 1, so my new answer is 1.00434 times 10 to the 112. Here's another example. I have a negative exponent 2 and a positive 2. To convert this to a positive 2, I'm going to have to add 4. That means I'm going to go 4 places to the left. 1, 2, 3, 4. Which gives me 0.000732. And I'm going to add that to this decimal, 1.60. I'm going to add my zeros in. And I get 1.600732. This still fits the criteria. So 1.600732 times 10 to the second would be my solution. What happens if I need to subtract? Be careful about watching your signs here. So for this one, it's asking me to subtract my scientific notation instead of add. Again, I'm going to take my smaller exponent and make it my larger exponent. So I need to add 2, which means I'm going to go 2 places here. So I'm going to end up with 3.78 minus 0.0283. Add your zeros. I'm going to have to borrow here. I get 7, 1, that's 7 from 2 is 5, 7, and a 3. This still fits my criteria. Times, I converted them both to 10 to the 4th. Alright, now the rest of the problems you should be able to do practice adding and subtracting in scientific notation.